welcome to our first episode. We launched this Tokenomics DAO community, wrote a few articles, and gained some momentum. And we kind of thought we'll bring it into a new format and try out a podcast. So I've got Jason with me, who's also been part of the Tokenomics DAO. And today we really want to talk about Ethereum.
Yep.
Yeah. What I'll maybe do was I'll bring up the tokenomics diagram for myself, and then we'll walk you through, and we'll probably do this as an audio form, but then we can just see it. So maybe for you guys, I've just recently released these tokenomics walkthroughs where I've just walked through the whole diagram. And I think that's a cool point to start if you don't know anything about it. And yeah, maybe I'll do a quick rundown of what Ethereum is about. So yeah, it's a blockchain, public blockchain. That means everybody can join. Everybody can download a node if they have the hardware and join the network. And it's currently a proof of work consensus algorithm mechanism, and that means that transactions are validated by miners, and these miners will kind of, to get into the position to mine such a block and get rewarded for it, they will need to solve some math problems, let's call it that. So there's some interesting math problem they have to solve, and basically with that expend energy to gain the right kind of to validate a block. If they do so, they'll get rewarded for it.
And Flo, that's similar to how Bitcoin works, right?
Yeah, totally. Yeah. So Bitcoin is exactly, it's like the prime kind of example. You mine, and they've got this beautiful formula for if you mine a block, you get like 6.25 Bitcoin. Ethereum isn't that clear and that fine design that we have, but at least one thing that we know, that there's roughly 4.5% annual network issuance. Like of the supply, we'll get 4.5% inflation annually of new tokens coming into the ecosystem via mining. So that's just new supply that comes into the market. And then another thing,
Flo, does that number change, that 4.5%, or is that like hardwired into the blockchain?
I think that is hardwired. Yeah, I need to double check if that does anything, but I'm kind of like semi sure that that's sort of hardwired. Don't know. Yeah, for sure. So we can look that up for
Okay,
another episode.
so for somebody looking at it, they would say that okay, it's inflationary, but in a fixed format, like at a fixed rate.
Yeah. I can look up one of my articles. Maybe I've mentioned it in there. But yeah, anyway. So then I guess the other thing that's really interesting compared to Bitcoin, Bitcoin was this model where Satoshi, after writing the white paper, he just launched his mining and started mining, and that's actually where the first tokens got created. For Ethereum, Vitalik Buterin kind of came up with that and put in a lot of work in designing and defining how the system would work. And yeah, they had this pre-mine, and there's a lot of controversy around it. A lot of people were like, you can't do a pre-mine. That's not really fair launch like Bitcoin was. But anyway, so there were like 72 million ETH created prior to the start of the mining, and that went up to contributors, investors, foundation, and all that. So call it the Genesis supply. And yeah, that's of course supply that's available and can potentially hit the market. It's held.
They're all vested already. Like they're all able to hit the market now. Do you know?
Oh yeah. I mean, that's
okay.
Yeah. I don't know when they launched, 2015 or 16.
I think you don't have to worry. Like anyone who complains that it's not fair, I mean, I still hear people complaining that Bitcoin wasn't fair, right? But just because there are these whales that have a large number of tokens, and they were one of the first ones to start mining.
Yeah.
When I listen to people talk about Bitcoin, there's still dudes from the traditional side of the fence that say, "Oh, look at the concentration that Bitcoin has. It's not fair either." So I think in however you do it, you're gonna have people that are unhappy, right?
Yeah, yeah. And like parties on both sides are quite extreme, right? So there's maximalists, as they call them, on the Bitcoin side, and I think on the Ethereum side it's the same. So they will always have their stuff to fight about, and it gets quite extreme. I try to not listen to it too much, what these guys are saying, and because there's lots of nuanced voices out there that kind of try to find a neutral middle ground between these two, and neutrally try and assess both, right?
Okay. Yeah.
So a guy I really like to follow is Eric Voorhees. Like he's been involved in both of these ecosystems, and done a lot of work, and he's on lots of podcasts. I think he's like a really good, clear thinker on this, and yeah, he's on neither of both teams. He's just in for this, like the technology and advancing the whole field. So I think he's a great person kind of to see this through.
We'll have to
From
tag him
experience.
to the
Yeah,
video or to the podcast.
yeah. Yeah, yeah, definitely. He's one of those. So yeah, then we kind of have this Genesis supply that's on the market, and the mining supply. So both of these hit the market as supply, and users or people like us who invest and maybe want to buy some Ethereum, you can do that on exchanges, like centralized or decentralized exchanges. And whenever you transact with Ethereum, and most of the people know that, you pay transaction fees, and they're currently really, really high. I mean, so high that you pay like $30 for a transaction. And most of you guys have used this stuff, know this, right? It's just very, very expensive, and it's partly due to the to the system, the proof of work, and the fact that there's really a lot of people using this system. And that they're working on solving this by they're working on this Ethereum 2.0, and where they want to move to proof of stake and change the whole thing and make it more scalable, so that we can basically transact here and use less gas. And I think that's super important, because one thing that I think, if you kind of compare it to the internet, right? The internet, some back in, I don't know, in the 2000, it was far from frictionless, right? You would use it and it was really hard to use to do stuff, like to write an email even, or to even connect, because it was so slow. So people
You'd
didn't
wait
really
10
use it.
seconds for a page to load, but
Yeah, even longer.
Yeah.
But then now it's so easy to use, right? There's all this stuff. Like, I mean, we're doing this thing here using Zoom, and it's all pretty frictionless, right? To connect and
Right.
to do stuff on the internet. And I think if Web3 or crypto wants to get to mainstream adoption, they need to become frictionless as well. And part of that is that you have an environment that where you don't pay a lot of gas, so you don't have to think about executing a transaction, so that you can transact as cheaply as possible in this whole ecosystem, right? And that's, I think, one of the things that with Ethereum 2.0 that they're trying to achieve. So like these,
So
like I said,
before you move on, like just could you touch on with the transaction fee? People talk about gas. So there's also the gas price, right? And the gas price is to do with the price of Ethereum, is that right? And then the amount that you need, it has something to do with how much data you're actually trying to push through. Would that be correct?
yeah, I mean, like, there's a complicated, not a complicated formula, but it's a quite interesting way they calculate. They've got this Gwei unit of measurement, and then that kind of prices how much a transaction is. But then also the miners play a role into that, like how much you pay. Before they implemented this EIP 1559, then all of that transaction fee would go to the miners, some as tip and some as normal fee. and that would constantly lead to very high fluctuations and changes in these transaction fees. So the way they were calculated led to them being very volatile. Because they're kind of calculated that way, and because the network is so clogged up, right? So for a miner, they would only pick transactions to come into a block that pay the most, right? So that's how the market works.
Naturally.
Yeah. So there's that's kind of sometimes if you are trying to be a tight ass and get through some cheap transactions, you might have to wait for quite a while nowadays.
What does quite a while sound like? Like, say I only want to pay at most $5 or $3.
You have to wait forever. Yeah. Now I've recently seen this guy on Twitter, and he kind of said his transaction went through after 60 days.
Whoa.
Because we just recently had these low gas prices because not a lot of people were using Ethereum. I don't know why, but we had this point where not a lot of people were using it, and then gas prices were low. So his transaction finally went through after 60 days.
But when you say transactions, it's not just transferring of Ethereum coins, right? Like, how about the programs that are running on the Ethereum blockchain? Like, what do transactions mean when you say transactions?
Yeah, like so that's really the main innovation, right? That came from Ethereum is the ability to run code or to store code in a block, kind of like a transaction. So you could go to a website like Etherscan, and on Etherscan you can then look for a smart contract, and you can then see a smart contract from a page like Uniswap where you can exchange tokens. So you can see the complete code of that smart contract on the Uniswap website, and sorry, not on the Uniswap, on Etherscan, and you can see that it is basically, it's stored on the blockchain, this smart contract, and it has an address like your wallet has an address. And that's really the innovation in a way, right? So you can write a piece of coding, you can submit it to the blockchain, it gets stored there, and it has an address. So everybody knows, and that is what is immutable then, that this piece of coding, if you call that address, this piece of coding gets executed. And that could be all sorts of stuff, like what Uniswap does, right? So this liquidity pooling. So you commit money into a liquidity pool, and then other parties can access that liquidity pool to do an exchange, right? So I have token A and I want token B, and I just go to their Uniswap website and I give my token A and I receive token B. And what happens in the background, there's a bunch of smart contracts that hold liquidity from different parties who provide token A and token B pairs. And then you can tap into that liquidity. You pay a fee for exchanging that, and that fee goes to the liquidity providers. And all of that happens in these smart contracts. Or it could be something as simple as like a simple escrow, where you commit some money into the account, and if your goods have arrived and you tell the other party that the goods have arrived, or maybe that gets triggered automatically by something, then the funds are released to the other party. So,
and do all these actions incur a transaction fee or transaction costs?
Yeah. Like whenever you send something from one side to another, from one wallet to another, that's actually a transaction, because you want that, and you can see that here, right? So I've got Etherscan open, and wherever you go, you can see all the transactions. So I can go to my wallet address and I can see all the transactions that I've ever done, and be that to send something to Uniswap or I'll get some tokens back. All of that is in there, and all that's kind of kept here. Yeah, and in these smart contracts, they can basically execute transactions too.
So then, when, let's say we now say that all transaction costs are really expensive, is that a function of the fact that there's a lot of demand for the Ether coins? Is that the reason? And then the price of, and because Ethereum now has a high price, and that's why the transaction costs are high?
I don't think it has a lot. It has to do with price. I think it has more to do with like the amount of transactions that people want to execute at a point in time. So there's this really
Okay.
cool website. It's called like TX Street or something. Maybe let's see if I can get it up. And yeah, it visualizes it. I'll put it in the show notes, but it's super cool. So it shows a bus, and it shows like, and this is like the real network, right? So Jason's just seeing this for
Gosh.
the first time, I think. So you can see here on the
Yeah.
side, there's transactions coming in from Tether, from Maker, from USDC, from Uniswap, and all these different from MetaMask, and they're all queuing up for the bus. And then there's the bus, and the bus has like, oh, 144 guai is like the gas that's going into this thing, and whoever's willing to pay that much, he's getting on the bus, right? And you can see the next
Yeah.
bus, they're even charging even more. And the bus has like a certain size of megabytes kind of that they can take in and transact
Yeah.
with, right? So what is happening in Ethereum is there's just more people wanting to transact than the system can currently handle. So it's just clogged up. You see the line here at the bus, right? And it's
But what
small
does that
buses.
mean? So let's say we bring it back to traditional economics 101, right? Supply and demand. So there's so much demand for this stuff. So how does more supply come on?
This is more supply for handling transactions.
Yeah.
Yeah, I mean, this has to do with scalability of the system, and I guess that's kind of something that with proof of stake and with sharding and layer 2 and rollup that they're trying to solve. So one of the ways that currently this whole scaling issue is tackled is with layer 2, and layer 2 means you do a lot of these transactions, right? So we're still looking at this bus, and you do a lot of these transactions off chain. You don't actually do them on the blockchain, but
Hmm.
you keep track of them in something that's called like a Merkle tree. So you keep track on who pays who with the
Yeah.
wallets. So you can
Yeah.
have exchanges on there. You can have synthetics swap programs on there, and they transact. And
Yeah.
you keep all of this in this Merkle tree. And then once in a while, you do a batch of all these transactions, and you 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 write them back onto the Ethereum layer 1 main chain. And so you have like, think of it in this bus analogy, right? So you have like all these people wanting to fit into one bus, and now you're taking all these people, putting them somewhere else, and then you compress that, and then you only put that compressed version into the bus. And the cool thing is, if you're using this layer 2 thing, you still have like the security of the mainnet of Ethereum, right? Because the whole transaction, all of these transactions that happen, they're still secured by the Ethereum network. You can reconstruct any of the states that have happened. So yeah, that's really one way they're trying to scale, and in your terms, trying to introduce more like supply for transactions to be handled.
Wow. Okay.
Yeah.
And
So
very interesting. So this compressed data that then gets on layer 2 that then gets transferred. Does that also have all the information embedded in there, just in a compressed format, or is it just the, let's say, the balance, the settlement of the different transactions?
no, it would have like um, you can reconstruct the complete state out of that.
Okay, so it's
Yeah.
not just the aggregated final plus minus whatever, right? It's actually every bit of information is still somehow in there.
Yeah. Yeah. So yeah, it's pretty cool technology, and I think like Ethereum 2.0 is even working on sides in making layer 1 more scalable, and they're introducing like a whole lot of different topics. And I don't think I can get into the technical details of sharding and how that works, but yeah, what they're essentially trying to do in this bus analogy is trying to make the buses bigger so that we can get more transactions onto this bus. and yeah, that people have to pay less to get their transactions stored on the blockchain. You could also increase the frequency, so that, yeah, that's like a whole nother debate, right? Do you want to have the bus move faster, bigger buses and whatnot, right? So that's all ideas that can go into how to scale blockchains. But yeah, I think like I don't really think this has a lot of impact on the token itself, other than people might be leaving the ecosystem if it has too high gas prices, right? So if the usability becomes so terrible that that you think like, oh man, I can't do this anymore. Like, I don't know, if you go to another blockchain like Solana or Avalanche or Terra, even there you can do a transaction and it's quite cheap to do. So you can lend, borrow, you can send money to someone, do all that kind of stuff, and it's like dirt cheap. So you almost forget about it. But on Ethereum, you're always like, oh god, I can't move coins from here to there because it's going to cost me 30 to 40 bucks to do that. And that is,
so there's a
that could be
friction.
reason
There's a
for,
friction.
yeah. There's so much friction that people might be leaving the ecosystem. I don't have any numbers, but that might be something interesting to look into to find out, right? If that actually impacts interest or network effects for that token.
Yeah, that would be really interesting, right? Because at some point, it definitely becomes a hindrance that's big enough that people will then look to leave, right? It's almost like a taxation in a country. If the taxation, everything might be running really well, but if you're getting taxed 95% on profits, you're gonna go work somewhere where the infrastructure is maybe not as good, but you get to keep the surplus. And you mentioned those other blockchains earlier, right? So Avalanche, Solana, Terra. In terms of, besides, maybe we can do that conversation another time, I'm not sure, but from a usability standpoint, besides the costs for transactions, for developers, is it just as easy to make their apps on those blockchains versus the ERC20?
Yeah, I guess it
blockchain?
really depends. It really depends on what they kind of what the goal of that blockchain is. They all have like different approaches and different ways to do this. Like for instance, if you go to the Terra ecosystem, they've got like a completely different programming language. So they use, I think, WebAssembly to develop code. That means you can use languages, I think like Java or something similar, and Solidity be like more like maybe like JavaScript. And so the coding is completely different, and there's not as much reuse. And every ecosystem kind of has their own thing. Some larger blockchains like Avalanche, they are EVM compatible, so they can run the Ethereum virtual machine. So you can kind of take your coding from Ethereum and deploy it to Avalanche and run it there. So that,
okay.
Yeah, I guess that'd be a and to me, that's always something that's really interesting, because then they're kind of in a way tapping into the network effects, right, of the Ethereum ecosystem. Because then if somebody builds a cool app, let's say Uniswap builds something, and they have it doesn't cost them much to move it to another ecosystem, they might just do it, right? If it just costs them like 10 hours of development to deploy it there, they might just do it. But if it takes them 1,000 hours to rebuild it on WebAssembly, they won't. So that's kind of how I think also apps grow and distribute to other ecosystems. And I think it's a cool way, in a way. There, a lot of these are like compatible with each other, especially the ones that support EVM.
Will there be bridges to allow these apps to link to each other over different blockchains?
Yeah, totally. I mean, there are, between most of them there are bridges. So maybe I'll show this one here. There's a nice image I found on Twitter, and I actually
I
wrote
just want to look at the bus all day.
yeah,
So
the bus
therapeutic.
looks really interesting. Yeah. So there's this one here. Um, it's by far not complete, but it
Mhm.
shows that, and I'll link that in the show notes as well. It shows like that Ethereum is connected to to Terra and Solana using something called the wormhole. So you can go to
Okay.
wormhole, and that then works with the bridge. And the bridge kind of, the wormhole got hacked recently in this major thing where they got like, I don't know, 120,000 ETH. A lot of money got yeah, got forked out of the system with some interesting dynamics where they use the smart contracts on Solana to pretend that I think they had sent more money over than they actually had, and then they managed to bridge it over to Ethereum and get it out of the Ethereum smart contract, because that's what a bridge does, right? A bridge is kind of, you have a contract on the Ethereum side and on the Solana side, and if you want to move your funds over, you send your tokens to that smart contract and it's locked. So you put 10 ETH into that contract and it's locked. And then on the other side, you get released or minted some other token in the Solana ecosystem that says, hey, I am a voucher to get back that ETH that you have on Ethereum, right? So you can
Right.
take that voucher then, and it has the equivalent amount of that. You can run around with that on Solana and use it for all sorts of stuff. And if you want to go back to Ethereum, yeah, you can hand in that thing and you can trade it in for your Ethereum again. And the smart contract on the Ethereum side will then release your tokens again, so that you can use them again, right? And that's kind of the mechanism. Yeah, maybe if I find it, I can link that too. There was this Twitter thread explaining how they kind of tricked that smart contract to tell the other side that it had way more Ethereum than it actually had.
Mm.
But
So they
without
found
bridges,
some
yeah,
loopholes.
they did, yeah, and it happens all the time. And I think that's important, and it's good for of course, not for the people who lose money, but um, it kind of helps evolving and securing the whole thing, right? So if something blows up, the community is usually really fast in fixing it, auditing it, and making it better and stronger.
Yeah.
And that's a really cool way of evolving, right? It has something of like nature. Um,
Yeah, like
like
small steps, right? Small
yeah,
evolutionary steps rather than massive, just binary events.
yeah, and that's like how the whole ecosystem works. And what I really like about it, that it's made of people that are builders that go out there and try stuff, and they try it and then see if it works or not, and let it get battle tested. And
Mhm.
yeah, so that's kind of how these bridges between the ecosystem works. And I think that's a whole nother interesting concept, like how tokenomics flow between these different systems, what that does, which I totally haven't thought about. It's just, yeah, that's just an idea.
Yeah,
Maybe we can look into that someday.
we have to. I mean, let's say coming back to the non-digital world, with all the stuff happening globally, you always get these threats, right? Like that. Oh, if country A doesn't behave, they're gonna get sanctioned, and if they get sanctioned, they're cut off from a certain system, or SWIFT, let's say. So I'm wondering if there are parallels with how to simulate, maybe by studying this, we get a better idea as well as to how different actors in the real non-digital world will
Yeah.
react to getting their quote unquote wormholes cut,
You mean like Ethereum would sanction Solana if they don't,
something like that.
yeah,
Now,
implement
I'm
some
just wondering
feature?
who's the independent state of Cardano in our non-digital world.
Not connected to anybody else. Yeah,
Yeah,
I don't know. That'll
maybe.
be an interesting thing to find out, who that could be. But yeah, I mean, the fact that it is, I guess, decentralized means that I think like almost anybody can build up a new bridge, like this wormhole. Those are just like smart contracts, and these smart contracts are then secured by something in that ecosystem, and you could easily replicate that and build another bridge. So I'm sure there's multiple bridges going between these two or multiple ecosystems, right? And that's all possible. And I think that's something that in the real world you don't have that openness, right? So if Swift, because it's like, oh no, we're not going to let Russia transact anymore, then yeah, Russia has to. What are they going to do, right?
Yeah. Or if you're a trucker.
Yeah, you all of a sudden can't use your funds anymore. Can't access your funds. Yeah, I don't know. Maybe that's worth a whole episode, I think.
Yeah. Yeah.
To look into how they actually, yeah, how it works for them, right? They now, the people in Canada, the people who criticize the regime, they get their funds frozen. So what possibilities do they actually have in the current world, in the traditional finance world? Like, if they can't use their credit card to buy stuff anymore, how do they do, right? And then on the other side, you have to think like, cool, all of this crypto Web3 stuff is great, but like if you can't use it to buy coffee yet, then, or buy your groceries, there's also kind of not helping these people, right? Because storing wealth in it, but if you can't buy food, then you still have to. And that's interesting then again, right? So if you, let's say you have all your money in Ethereum, and even though you've gained a lot or whatever, if they cut you off from centralized exchanges, then you can't get your money out of there.
Yeah, then it's no different from you playing like a computer game where you're in this virtual world where you've made a massive fortune, but you just can't. You still got only $10 in your bank account, right?
Yeah, like a millionaire in World of Warcraft.
Yeah,
doesn't help you much. Yeah, that's pretty interesting, just to think about how that will work. I mean, if you could get other people who own goods to transact with you, then that'd be okay, right? If I could get the guy who, I don't know, the hair cutter to cut my hair and I'll pay him with Ethereum, he'll be fine with that. That'd be okay, right?
What will probably happen in the meantime is like a black market will come up or spring up where I might be a non-trucker that officially supports the current regime, and I'll take your Ethereum and I'll sell it and I'll give you cash, or I'll buy you your coffee, right?
Yeah. I mean, like they also I read this thing that some Canadian banks or the government told the banks to block these wallets from doing stuff. And I mean, like, yeah, it's interesting, but they can just create a new wallet, transfer their funds there, and then I mean, the government can trace it because they can see these transactions on the blockchain, but they would have to then issue another warning and say like, oh, we did not, there's another wallet that you also have to track, and then kind of who outpaces who, right? So he could send the funds to 5 different wallets that he just created, and he has a seed phrase too. And yeah, it's going to be hard to track and trace. And then if you do peer-to-peer, you might find somebody who's willing and interested to give you some fiat or goods in exchange for sending him tokens to his wallet.
Man, so interesting. This image you have on the screen, it just makes me think so much about the real let's say states, right, that have financial systems, and they have their own incentives to use the financial systems in different ways. And I know that just with the Olympics the Winter Olympics in Beijing, there was a lot of talk about how the Chinese central bank digital currency would be launched. or at least launched to a higher degree during the event. So I'm also thinking about how that would work with Web3, right? Like, what would the interfaces be when countries start going to having CBDCs? Just so much to think about.
Yeah. I don't know. Like a lot of them, they wouldn't necessarily be on an open decentralized blockchain system like Ethereum, right? Because the government wants to have control. So they still want
Yeah,
to control how they issue them. So do you know anything about how China has launched their digital yuan
I'm
in
not
the
sure
Olympics?
not really, not from the technical aspect, but I know that for a while now they've been trying it out in a few different cities. And I think at the Olympics, the big deal was they wanted to let athletes and tourists and visiting teams, right, use the network and be able to. I might be wrong, right? I might not remember it accurately, but they wanted to let these different dudes use their foreign currency and exchange it for the digital yuan or renminbi.
Yeah.
So I think it was a test case for that. And if China manages to pull that off, then you can imagine that the next time somebody in Singapore buys something from somebody in Thailand, they might be using this other network to transact rather than the US dollar SWIFT system, right? Like just like what you mentioned just now with transaction fees in day-to-day wiring, right? There's so many things to think about. Like, is this entity on a certain list that I shouldn't transact with? How long is it going to take? Is there a bank in the middle that's going to step in to say no, the wire shouldn't happen? And if the Chinese system suddenly pops up and says, hey, frictionless transactions between these two different countries, that doesn't include China, but we're happy to let you use the system. I think there could be a lot of interesting flow-on effects because I know that the Western powers that be, they're looking at this CBDC from China with a lot of, let's say, they're quite wary of it because I think it
Yeah.
erodes a lot of their power, right?
Yeah. I mean, yeah. And then, yeah, I guess, of course, yeah, US has an interest in not having um, other currencies stepping up, right?
Yeah. No, but
Yeah.
when I mentioned just now about, I'm pretty sure it's not going to be on a decentralized, definitely won't be decentralized, but I'm just wondering if those centralized systems would have bridges to decentralized systems and whether it would be a little bit less um, cumbersome than how things currently run. Like, would that maybe even impact things like the need for stable coins and things like that, right?
Yeah. Yeah. I don't know. Like I can only think of Ethereum. And the way stable coins work, most of them, so like Tether or USDC, there's a bank behind it,
Mm.
right? So
Hmm.
there's something like these guys, and they then have dollars or something equivalent to dollars, and they hold it. And for each and every dollar or equivalent they hold, they issue something on Ethereum, right? So they create like
Right.
a USDT or a USDC. Now you can go into all sorts of discussions and investigations if it's really completely backed. And
Yeah.
of course, there are also corporations. They have to make money. If they just hold plain dollars in a bank account and then put them onto Ethereum, they're not going to make a lot of money, right? But if they put this into
Yeah.
other financial instruments, then yeah, they might they might be able to make some money, but then the whole backing thing might not be as secure and safe.
So we're back to the fractional reserve system.
Yeah, yeah, but like,
Yeah.
and I think to get to your CBDC question, I think they would, if they wanted to get something like digital renminbi onto Ethereum, they would have to do that in a similar way, right? So they'd put these into an account somewhere, and yeah, and then these would then be able to be kind of like a wrapped or a token version of them that then get transacted on Ethereum, and you can exchange them back into that other token. I could imagine something like that happening, but I don't think the real thing would be on Ethereum.
Yeah.
Yeah. I don't know.
Interesting.
Yeah. Maybe one thing that we haven't talked about on the Ethereum side is maybe we can talk about the different token standards. Yeah, because I think it's really something super interesting that the ecosystem has built. Because like if you think of Bitcoin just has Bitcoin on its network, but Ethereum has Ethereum and a whole stack of ERC20 and ERC721 tokens. So on top of the Ethereum network, there are tokens like Uniswap, like Ohm, and many others that are also tradable on exchanges that have some sort of value, and that sometimes even have a utility with different protocols, or and that utility can be governance tokens like Uniswap. That means if you hold them, then you can vote in a governance proposal. And that's all kind of this ERC20 token standard. So you have this token standard, and if you want to create a token, so if let's say we're thinking about that, for the Tokenomics DAO, we would like to launch our own token, then we could launch that as an ERC20 token, right? We could name it the TDAO token or something like that. We could decide how many of the tokens we want to issue, and then we just have to implement our own token contract based on the ERC20 interface in a way, right? So that then determines that you can transact with it and do stuff. Yeah, and then we could use that and trade with it, right? So that would be like the ERC20 side, and that's like the typical tokens that out of the Ethereum ecosystem. And of course, other blockchains have that too. They have their own tokens that can be created on top of the platform, right? Because a lot of ecosystem, be it the bankless DAO, they really thrive from having such an ERC20 token that can be distributed among the community, that has some sort of value, that captures some sort of value, and that can be used to have some utility. And then there's the ERC 721 tokens, and there would be non-fungible. And fungible is like, first time I heard it was like, what does that even mean, right? But
did it remind you of mushrooms?
It did in a way, yeah. But I guess like if you think of it as like a house or a piece of art, right?
Yeah.
Like every house is in a way unique. So I can't just exchange my house for your house. Whereas with an ERC20 token, if I have a uni token, I can just exchange it for a uni token. It's like, doesn't matter which one you have. But with a non-fungible, that's really the thing, right? It would I can't just change one for another. They're not exchangeable for each other, really, right? And that's what this contract is about. Yeah, and that's how the whole NFT space got started, right? That's the whole idea behind it. That you have this representation of, I guess, ownership of something, right? So the way these Bored Apes or the CryptoPunks, you've seen these profile pictures that are sold for millions and millions of dollars, is you have this this hash. And I've got a really cool example. Maybe I can just bring it up, that I recently sent to a guy who wanted to know a bit about NFTs. And I sent him this picture, right? So there's this, so the picture has like, it shows an image of a cat, right? And that's kind of like the input that you have. And then there's a hash function, and that hash function generates a hash out of it. Hash is basically just a string of that digital document, which is a photo of a cat. and then the hash function creates that string, and it will always create the same string if you run it again on the same image. But if you change just one thing on the image, and in this example, they pull a whisker from the cat, and that means the image is like slightly different. It could be just
Everything's
one pixel.
changed.
Then the complete hash is different, right? So what this does on the Ethereum blockchain, you store that you own that hash in an NFT, right? And that's the whole thing. So you own the hash of that CryptoPunk picture, and if somebody just slightly changes it, the hash would be different. It could look different and all that kind of stuff, but you can claim that you own this original piece, and you can trade that, right? Because so you can sell that to other people who might think it is valuable to do so. Yeah. And that's the whole idea behind it, I guess. If that makes sense.
Yeah, crazy. And so if I just had the hash, would I be able to recreate the picture, or I would need to know the cryptography that was used to create that hash?
No, it's one way. Like you can't turn the hash into the image. No. It's just that one way. But you can do it over and over again. It will come to the same result every single time, right? Yeah, and I guess that's also like fundamentally how blockchains work, right? They just create these like a block is basically a hash that is created over all of these transactions, and then that hash is included in the next block, so that you have this immutable reference to the previous block saying, oh, hey, we've created this hash. So if you go ahead and change anything in it, the next block won't believe you, and the reference will be broken because the hash doesn't match
comes
anymore.
Up will be different.
Yeah. So that's the whole idea behind it. Anyway, so that's kind of these two different token standards. I think they're really important. Cool. Maybe let's go back to the image and see if we have anything that we haven't covered. Maybe a part of Ethereum that has recently changed. I don't remember exactly when it was. Maybe it might have been October. Anyway, they released this implementation pack EIP 1559. And with that, they introduced burning of transaction fees. And the idea was to stabilize and get rid of this volatility in transaction fees. You know, I said this in the beginning, like you had days where you paid like, I don't know, $270, and then the next day you only paid like $30 for a transaction, and it would wildly fluctuate. So they built in this mechanism basically that couldn't happen anymore. And on top of that, they also made sure that a significant part of this transaction fee that goes off the transaction is actually burned, and the rest goes as optional tip to the miners. Might get you into the block earlier. And there's estimates that there, might be like 70% of transactions fees, burned. There's a website called, I think, Watch It Burn ETH. And
these names, man,
Watch the Burn. Yeah. So this website, it's called watchtheburn.com. It will like monitor the amount of burn, right? So in all time, we've got like 1.8 million ETH burned since October, since this thing has been launched, right? And that's like, oh God, $5 billion US dollars that have been burned and taken out of circulation, right? And that's the interesting part from a tokenomics perspective, is that in the beginning, I said we've got like 4.5 annual network issuance that come via mining, and now we've introduced this new, or the community is, and that's also really interesting, right? So the community has decided to implement this new feature, and they've all of a sudden said like, okay, we don't want to have this like crazy inflation anymore. We want to actually do something that maybe be a bit more deflationary or reduce that inflation a lot, right? And this is actually what this could do. And there's some interesting guys out there that have analyzed this and come to the conclusion that before we merge to Ethereum 2.0, that Ethereum could become deflationary. so that actually the total supply, or the circulating supply of Ethereum could go down, because we're burning so much, right? So with the more transactions that happen in this system, the more ETH we're going to burn. I don't think they
And
have any of
is
these.
this
Yeah.
is this burning rate fixed, or do we know what the burn rate is?
Yeah, I'm just trying to find out.
Like, is it
This
constant,
one,
or does it fluctuate based on how crazy the transaction prices are?
yeah, I'll have to. I don't recall this from memory exactly how the burn is calculated. Maybe I can look it up um in this article I wrote about Ethereum. But yeah, maybe we can talk about it in another session. But the
Yeah,
only thing I do remember is like that they had these this like estimate of roughly 70% burn, um of where it would end at. Yeah. And then they
and
had a
who
bunch of
loses from the
charts.
burn? Like, it's all good to say like, hey, let's make our currency stronger, right? Like, let's make it deflationary, help the savers out. But there's always pushback because some people like an inflationary environment, right? So in this case, who's the which party gets hurt? Is it the miners because they get paid less?
Yeah, yeah. I mean, miners were not really happy with this change as far as I can remember, because they would get paid less.
Mm.
And so that was one thing. But yeah, I mean, I don't think, like, for all of the investors and holders of ETH, of course, this is a great thing if we reduce supply. But
Yeah,
the other thing that you have to think about is kind of like, if the community could just change something like that so easily, that's in a way concerning, isn't it? Right. So
yeah,
if they can change
yeah,
this, what are they going to come up with next? Right. And
yeah.
that's what I always think. That's, I'm not a Bitcoin maximalist, but that's what I really like about Bitcoin. It's like steady, it doesn't change. That's just the system how it is, and they don't muck around with stuff like that. But here they've introduced something like that, and I mean,
Very
it's a cool
interesting.
thing
Yeah.
for investors, definitely, and I like it that they're that they're gonna, kill some of the supply or take it out of circulation. But then, you're gonna ask this kind of like philosophical question: what might they do next if they start doing that?
Yeah, exactly. Because if say you just spent $1 billion raising funds so that you can become the world's best Ethereum miner, sorry, maybe a lot more than $1 billion, um, and then this rule change rolls out and changes your whole ROI.
Yeah, your business is screwed. Yeah,
Yeah.
just because the community thought like it'd be a good idea to do this.
So the Ethereum community is like direct democracy Switzerland, and Bitcoin's like still following the Ten Commandments.
Yeah, they won't change.
Yeah.
Yeah, I mean, yeah, it's really interesting, uh the dynamics here, I guess. um yeah, cool. I guess, yeah, maybe we'll go into the whole Ethereum 2.0 in another session, um because
Yeah.
yeah, maybe that will be a bit too much for this first round
My
of
small brain is
casting.
well and truly fried.
Yeah. Mine is too. So yeah, cool. Do you have anything else to wrap it up?
Thanks for the run through. I really enjoyed it, and it's just cool to learn and cool to see how this, in a way, this experiment's running, right? The different experiments that are running concurrently, and to me, it feels like a illustration of human psychology live. Group psychology, group behavior, um, behavioral economics.
Yeah,
You
yeah,
take
yeah.
away that big dog government guy in the middle, and you let the chimps run free. Seeing how they organize themselves, it's super interesting for me.
Yeah, yeah. it reminds me of this, like, how must it have been to be one of the first immigrants to the US, to this new country, right? You just go there and do
Mm,
whatever you want. And
mm,
that's kind of how I always think about this Ethereum landscape. It's like this super open ecosystem, and you can build whatever you think you like, and then you can test it and see if it works, right? So they built this
yeah.
automated market maker, and it worked, and it's wildly successful and a core piece of infrastructure now. And there's so many other new projects coming up, like Olympus DAO, right? That's like one that I found super interesting. These guys launching this protocol owned liquidity. That's worth a whole nother podcast, right? But they launched this idea and then they test it live. So they've launched somewhat last year, and the token went up to, I don't know, $800, $900 per token, and now it's gone down to like 50. And so it's this whole experiment that's going on of what you can do with these tokenomics, and how can they evolve. And that's not necessarily a bad thing that the token went down to 50, only if you bought at 900, of course. But um, maybe this will still, once it grows and evolves, be a really cool stable token that is backed by a whole lot of different assets, and there's so many cool experiments that just go on and that happen freely without being um, regulated and stopped in their infancy, because yeah we yeah they kind of have to be thought through by some central authority. So this
Hmm.
is, that's kind of what I love about this space. It's just this wild evolution of just building stuff that people are interested in, that works, like DAOs. I mean, that's, another time.
Another time. All right.
Yeah, cool.
Then thanks so
Thanks
much,
for joining us.
Flo.
Yeah,
Looking forward to the
thank
next
you.
one.
All right, thanks everyone. We'll yeah, certainly have a second one of this.